Welcome back to the Super Memory for Schools program. My name is Thuy Thuyn. I'm in charge of 10th grade math. Now we will move on to part 2 of theme 1, review of linear and quadratic equations. In the previous part, we reviewed linear equations. Today we will review the quadratic equation with its form ax squared plus bx plus c equals 0. You can see that for case A is 0, ax squared equals 0, so some forms of bx plus c equals 0. This form is converted to that in the previous part, so the steps to discourse are similar. It's simple, right? Let's try. When a is 0, we will solve the equation as in the previous part, ax plus b equals 0. For the case a isn't 0, the equation still has x squared, so it's the quadratic equation. In other words, an equation is a quadratic one only if a isn't 0. The quadratic equation has an important and familiar expression. It is delta. Delta equals b squared minus 4ac. You will consider 3 cases of delta. Delta is greater than 0, delta is 0, and delta is less than 0. For the case delta is greater than 0, the equation has 2 distinct roots. x1 equals negative b plus the square root of delta over 2a. X squared equals negative b minus the square root of delta over 2a. Delta equals 0, so the equation a double root x equals negative b over 2a. Delta is less than 0, so the equation has no root. You learned these in grade 9. In quadratic equation, there is one important theorem. It is Vieta's formula. The form ax squared plus b plus c equals 0 is considered quadratic equations when a isn't 0. And it has 2 distinct roots, x1 and x2, where delta is greater than 0. With these conditions, S denoted 2 roots, sum equals negative b over a. P denoted 2 roots, product equals c over a. There is one tip to remember these formulas, which is
tổng bà tích k.
Here I will give you a formula that is often applied to solve the equation. It is x1 squared plus x squared equals s squared minus 2p. This formula is proven in grade 9, therefore in grade 10 you can use it without proving it. Because 3 cases of delta and Vieta's formula to discourse quadratic equations, we have some more notes to meet the conditions of questions because this equation has many types of exercises. I will mention some of them again. For the equation ax squared plus bx plus c equals 0. If the exercise requires that the equation has 2 distinct roots, we have to consider conditions a isn't 0 and delta is greater than 0. If the exercise requires that the equation has 2 roots, which can be 2 distinct roots or a double root, we will consider conditions a isn't 0 and delta is greater than or equal to 0. If the exercise requires that the equation has a double root, we will consider conditions a isn't 0 and delta is 0. Here are 3 requirements of the exercise. It can have more. For example, the requirement is that 2 roots of the equation of 2 opposite signs. This equation is a quadratic one since a isn't 0. A quadratic equation has 2 roots that are negative 1 and 3. One root is negative, another is positive, so the roots of 2 opposite signs. The product of a negative number and a positive number is always less than 0. Therefore, 2 roots of the equation are of 2 opposite signs if p is less than 0. P equals c over a and is less than 0, so the formula can be equivalent to a times c is less than 0. Normally we use the formula a times z is less than 0 since it's easier to solve a product equation than a quotient one. So if 2 roots of the equation are of 2 opposite signs, a times c is less than 0. 2 distinct roots of the equation are of the same sign. They can be both positive or negative. For example, x1 is 1 and x2 is 3, so both of the roots are positive, or negative 1 and negative 4 are 2 negative roots. The product of 2 roots with the same sign is always greater than 0, which means p is greater than 0. Moreover, we have 2 distinct roots, delta is greater than 0. Next, 2 distinct roots of the equation are negative. In the previous example, if 2 roots are of the same sign, we consider 2 cases including 2 roots that are both positive or negative. We only consider the product because it is greater than 0 when 2 roots are of the same sign. In this example, the requirement is 2 distinct negative roots. We will consider the sum that is less than 0. The sum of 2 negative numbers is negative, so s is less than 0. Delta is less than 0 so that the equation has 2 distinct roots. The sum of 2 negative numbers is less than 0. The product of 2 negative numbers is greater than 0. These are conditions to meet the requirement. Next, to have 2 distinct positive roots, the conditions are delta is greater than 0, the sum of 2 positive numbers is greater than 0. The product of 2 positive numbers is greater than 0. Therefore, s is greater than 0 and p is greater than 0. Actually, there are so many formulas, it would be better if you can remember them. If not, you have to discourse like the ways I explained. For example, the requirement is to have two distinct positive roots, so we separate it into two smaller requirements. First, to two distinct roots. The condition is that delta is greater than 0. Second, to have two positive roots. The condition is that their sum and their product are greater than 0. So I've shown you some more formulas. I will apply them to solve and discourse some exercises. Example 1. Solve and discourse the following equation for m plus 1 times x squared minus 2m plus 1 times x plus m minus 2 equals 0. I see this as equation 1. To solve and discourse it, you need to consider the following cases. Case 1. A equals 0. So a is m plus 1, so 0 times x equals 0. Solve this equation, so when a equals 0, m equals negative 1. Replace m by negative 1 in equation 1, and you get x minus 3 equals 0, so x equals 3. Case 2. A isn't equal to 0, so m isn't equal to 1. This equation is a quadratic equation. We will consider delta to solve this equation, so we will calculate delta first. Delta equals b squared minus 4ac. I will show you the answer is 8m plus 9. You can recalculate to check the answer. Please pause the video to calculate and check when your answer is similar to mine. We will consider three cases of delta. Delta is greater than 0, delta is 0, and delta is less than 0, so m is greater than, equal to, and less than negative 9/8. When delta is greater than 0, the equation has two distinct roots. x1 equals 2m plus 1. Plus the square root of 8m plus 9 divided by 2 times m plus 1. x2 equals 2m plus 1 minus the square root of 8m plus 9 divided by 2 times m plus 1. When delta equals 0, the equation has a double root, x equals negative b over 2a. When delta is less than 0, the equation has no root. So here are steps to discourse the equation ax squared plus bx plus c equals 0. Case 1, a equals 0, convert to linear equation to discourse. Case 2, a isn't equal to 0, so the equation is quadratic. We will calculate delta, then consider three cases of delta. The separate exercise is quite long, so in the test, the exercise requirement is rarely to discourse all cases, just to meet one requirement. Example 2. Find the values of m so that the following equation has two roots with opposite signs. It means that you don't have to discourse all cases. The requirement is only to have two roots with opposite signs. This is the equation ax squared plus bx plus c equals 0. To have two roots with opposite signs, the product of a and c is less than 0. M squared plus 1 is a, 2m minus 1 is c. So m squared plus 1 times 2m minus 1 is less than 0. This is a product that is less than 0, which means these two factors are of opposite signs. Look at m squared plus 1. It is a square, so it is greater than 0. Therefore, it is positive and 2m minus 1 is negative. Solve this inequality and we get m is less than 1/2. This exercise is quite short, and the conclusion is, if m is less than 1/2, this equation has two roots with opposite signs. Move on to the next example. Find the values of m so that the following equation has two distinct positive roots. X squared plus x minus 2 times the difference of m and 1 equals 0. A is negative 1, b is negative 1, c is 2. Multiply by the difference of m and 1. You have two distinct positive roots. If anyone doesn't remember the formulas, we will separate the requirement. First, to have two distinct roots, delta is greater than 0. We don't need to consider a because it is equal to 1, isn't 0. Then to have two positive roots, their sum and product are greater than 0. So three conditions are delta is greater than 0, s is greater than 0, and p is greater than 0. Apply the formulas delta equals b squared minus 4ac. S equals negative b over a. Negative of negative is 1 is 1. 1 divided by 1 is 1. 1 is greater than 0, which is true, so we can remove this inequality. P equals c over a. C is 2 multiplied by the difference of m and 1 divided by 1. This quotient equation is greater than 0, so this inequality can be removed as it is true. Solve this product equation and the answer is m is less than 9/8. For this quotient equation, we can divide two sides by 2, so m minus 1 is greater than 0, then m is greater than 1. Combine two conditions, we get the final answer, m is greater than 1 and less than 9/8. So to solve example 3, we do two steps. Step 1, you need to remember these formulas. If not, you have to separate the requirement like my instruction. Step 2. Apply the formulas to solve equations. Combine the roots to get the final answer and conclude the answer. So we've reviewed quadratic equations. Ax squared plus bx plus c equals 0. When a is 0, we convert the equation to the linear equation to discourse. When a isn't 0, the equation is quadratic. We have to consider 3 cases. Delta is greater than 0, delta is 0, and delta is less than 0. If delta is less than 0, the equation has no root. If delta is 0, the equation has a double root. If delta is greater than 0, the equation has 2 distinct roots. For this case, we need to remember Vieta's theorem. Remember that S equals negative B over A, P equals C over A. So in this lesson, we have reviewed linear and quadratic equations. Thanks for your listening. Goodbye and see you next time in the Super Memory for Schools program.